for Engineering Education at the National Science Foundation. His responsibilities include a number of programs. These include, for example, cultivating cultures for ethical STEM, the professional formation of engineers, revolutionizing engineering and CS departments, or the RED project, and many others. As Proctor said, NSF is the funder, the sponsor for this work, and so it's a pleasure to welcome Elliot.
And this is the clicker, I guess. So thank you. Proctor is very kind about talking about my support of this, but I have to point out that even though I am currently the managing program director for this project, it was really funded under Donna Riley's watch when she was the program director before me. So really a lot of credit should go to her. I want to talk a little bit about how NSF looks at engineering education and the role of, and why we were interested in this project, and what we see as the role of professional societies. So first of all, we're all familiar with this pipeline metaphor. And the problem with the pipeline metaphor is multiple. First of all, it treats pathways through engineering education as a single pathway. And of course, we know that there are many, many different kinds of pathways that students can go through. It only includes one aspect of the system, that is the universities and colleges with engineering programs, and ignores all the other pieces of it. And from a point of the, when they talk about the leaky pipeline, what it does is it treats the pathways or the students as something that can be fixed, right? So as the students are sort of not part of the system of fixing it. So, and as engineers, we go in and we can tighten up the joints and put in some seals and do those things and act on the students to make the system work better, not considering things like student agency, for example. And so for all those reasons, and this is not original to me, these comments, I got them from Alan Cheville. So in 2015, we've had funded a workshop that was run by Alan to look at these kinds of aspects of engineering education. And you're not going to read this, but what I want to point out is this is actually an outcome of the project, and this is the engineering education as an ecosystem, where there are multiple pieces to it that all influence each other in proximal and distal ways. So, we can think about faculty acting directly on students, but that big blue thing sort of in the middle, a little bit towards the top, that is professional societies. And so professional societies can certainly influence engineering education, perhaps in a more distal way, because they're not always working directly with students, although sometimes they are. They're certainly, and they're not always working, you're not always working directly with the engineering programs, although sometimes you are. But, there are multiple ways that you can influence the system. And just like in an ecosystem, there's these compound effects that sort of travel through the system, so that a piece that does something over here can impact what's going on over here. And that's really the way we see professional societies. And from an NSF standpoint, I'll talk about the programs in a minute, but we have not traditionally looked very strongly at the role of professional societies in engineering education. It's traditionally been, as we're going to get, I'm going to go into this, it's traditionally been about undergraduate programs directly. So if I look back at my core programs, my research programs, that's the way it's been done. So the program was originally called Research in Engineering Education back from 2010. In 2015, we changed that to Research in the Formation of Engineers to align it with a new initiative called Professional Formation Engineers. And what that does is expands how we think about the engineering education from learning to identity. This quote from Michael Fabre, translated by Gary Downey, I think is very useful. To form is more ontological than to instruct or educate, for one's entire being is at stake. So what we're talking about is a shift from understanding how students learn engineering to understanding how people become engineers. And both the terms people and becoming are intended to be construed as broadly as possible. So we are now looking at it from the entire range, K through gray or pre-K through gray even, the public understanding of engineering, and we have a very interesting project, for example, on engineers' understanding of the public and how that influences what engineers do. All aspects. I'm going to go through some of the aspects of the system and just of the types of things we're interested in just a minute. And so we can see that again, professional societies can play a role in all of this, particularly I think in the professionalization and socialization of students as engineers, because that's really a strong role that you all play, working directly with the engineering community. And so bringing students into that community in a way that they can understand what it means to be a professional engineer is, I think, a very important role that you all can play. And there's a list of elements. I'm not going to go through those, but those are the various pieces of the professional formation of engineers. And then what we've done is we've aligned our various programs with that particular framework. So some of the different things that we can think about as we think about what it means, what formation of engineers means. So of course everyone knows about the T-shaped professionals and what that means. We're looking at both breadth of knowledge and depth of expertise. The breadth of knowledge actually is interesting, that top of the T, because it's talked about in two different ways, which I both think are very important. One is, let's say you're an electrical engineer. So the downward part of the T is obviously your depth of knowledge in electrical engineering. What does the top mean? The top can mean two things. Top means you're going to need to understand at least some aspect of other engineering disciplines, because you're not going to be creating an electrical system in isolation to other aspects of engineering. You're going to be interfacing with mechanical engineers, materials engineers, biomedical engineers, depends on the particular project, civil engineers, the whole gamut. So you need to have at least some understanding of how the students are going to have some understanding of how their field interfaces with those fields. And then, of course, the other piece of it is the professional aspect of engineering, that is understanding things like communication, ethics, the socio-technical aspects of engineering, all of those. And so both of those are very important. And we see, of course, here the two NAE reports that really prompted a lot of discussion on these particular topics. Adaptive expertise is another important piece, and this really goes beyond, if you will, if the T-shaped thing is about skills, this is more about a mindset or a way of thinking, conceptualizing, and how to think, critical thinking. So what we want is adaptive experts. We want our students to become adaptive experts where they can take what they know and what they understand how to do and use that to confront new problems they haven't yet understood or have looked at. Of course, when you look at the NAE Grand Challenges, right, that's, I think, a good example of where this kind of adaptive expertise is needed, because these problems are so vast and so complex. The engineering aspects of it really you can't just fit into, be a routine expert and expect to be able to apply procedures and routines that you already know how to do to solve these particular problems. So ways to develop students, not just in skills, but as adaptive experts, is also an important aspect of formation. Of course, diversity is an important point, and this goes in multiple ways. So I'll just talk here about different ways we can think about it. And if we go down to the one about social justice, this really comes into the piece of thinking of engineering as a socio-technical profession, not just a technical profession. And if you're not familiar with Aaron Seck's article in 2014, it talks about the culture of disengagement that occurs as students go through engineering. So what she found was, following some students longitudinally, that their understanding or belief in engineering and its importance on impact of society decreases over their time as an undergraduate student. And this really comes about, I think, because of the history or the traditional way of doing engineering. It's all about solving problems. Let's solve this statics problem, let's solve this thermodynamics problem, let's solve the circuits problem, without strong connection to societal needs and issues of social justice, really. And so bringing that into engineering is very important. And here I'm going to point out the RED program that Leah mentioned. All of the projects really have some aspect of this, but I particularly want to point out that the University of San Diego, their RED project is completely focused around changing the canon of engineering to be one of humanitarian, engineering, social justice, and peace. And they're making their engineering program about that as the core. And then, of course, we have non-cognitive factors, or you might call affective factors, although there are some things here that I think are not necessarily affective. On the left is the cognitive model of information processing. This is how we often, cognitive scientists think about the cognitive aspects, but there's many, many others. So on the right is a social network diagram. This does not come from Julie Martin's work, but it's very reminiscent of her work on social capital, where she finds that students that come, first-generation college students, don't have the same kind of connection. So if we think about this as, on the left, that dense network is what these first-generation college students come with. Those are their connections within their communities, with their families, and all that. But those connections don't connect very strongly to the type of social capital you need to navigate the university environment. And so these students often are lost because they don't have the social capital that allows them to understand how to navigate those pathways. There's a lot of course, other non-cognitive things like motivation, identity, professionalization. All of those things are all very, very important. And of course, we know that active learning does pay off, and so we're not ignoring that as part of our program. But I will add that okay, that's not what I want to show. And also, opportunities for broader access by looking online. What I do want to point out is, I'll paraphrase something that Rich Felder said, if we could just implement everything about pedagogy that we've learned in the last 20 years and apply that broadly across the engineering education, boy, would we make a big change. Boy, would we we really would radically change engineering education. So in our program, we're not looking so much at understanding different active learning techniques and how they work. What I'm really interested in is research on impact. And in a sense, this is what this workshop is about. So I fund projects on understanding how changes diffuse, travel, translate, pick your favorite verb. For that, they all have sort of some subtle differences, but broadly speaking, they're the same thing. Understanding frameworks for measuring impact and determining what that impact could be. So those are all things I'm very interested in as a means to more broadly impact engineering education and how it occurs. And again, professional societies are really part of that because you have the ability to impact the field broadly, not just within a single institution or a single classroom. Obviously, K12 is an important aspect. We're not talking about that today as part of this workshop. This workshop is focused on undergraduate education, but clearly with next generation science standards, with the new AP engineering class that's being developed, those connections are also very, very important. And it's a means to really get students to understand what engineering is. So a lot of our K12 outreach now, a lot of K12 work is the robotics competitions. Let's get students excited about engineering. But what it really doesn't do as much is get them to understand what engineering really is and start to professionalize them as engineers, in a sense. And so I think that's what some of the K12 work that's moving forward could do. And okay, so this is the scalability piece that I was talking about and the impact, right? So the old funding model, fund PIs to develop a new innovation for their classroom and then publish that in peer-reviewed journals, create a website, give a workshop at ASCE or someplace like that, right? So who are you going to get? You're going to get the already converted. The new funding model is to fund large integrated efforts that can impact the system broadly. RED is one. I use EHR, the Institutional Community Transformation Track, as another, and Olga Pirakos, who's one of the program directors for that, is sitting in the back of the room. You can talk to her, I guess, if you're interested in that at some point. And the key piece about those two programs is it's not the focus is not, you don't start from I want to do this activity. You start from, I want to make this cultural change. And that's a very different way of thinking, but we believe it's a much more appropriate way, and it's a way to make that larger scale impact. And then, new dissemination strategy is considered models of change. So again, you don't just do an activity, you go into it thinking like, okay, take theories of organizational change and understand how that can be used to impact what you want to do. For the RED program and also for the IUZHR, create a national cohort of exemplars that people can then draw from and develop ways for scalability and adaptation. Kind of get away from the word dissemination, because dissemination sort of implies like the old model, I'm going to publish it or I'm going to create a website or something. We want is really active work across institutions to do that adaptability and scaling. And I think that's the last slide because it's not going forward anymore. So from my perspective, from the NSF perspective, what are the goals of this workshop? The goals are, I think, to do some of what this last slide says. Start talking around there. Don't just go away with, wow, I'm from ASME and ASCE has this really neat program and I think we could do that as well, and sort of do it on your own. Let's think about how to not just cross-fertilize, but cross-collaborate and create these larger partnerships that can work more broadly and at a larger scale to really impact the engineering education field. Because really what I'm looking for is what Rich Felder was talking about. What we want is that broad, radical change in engineering education.
I've got some furniture being
so have fun this next 2 days. I will unfortunately only be here today, but I'm looking forward to seeing what you all do. Thank you.